glue you here. Let's punch it very top. It's about optimization.
Which one? Are you on the project?
I'm just talking about sound. Yeah, we'll push them down.
What's that?
We'll push them down on Monday. That's kind of what you're supposed to do.
So,
What?
It's good.
For what?
Just moving the projects one Monday down, that's all.
okay.
That way you'll certainly have covered any material you need for each of them.
So nothing to do this Monday, coming Monday.
Correct.
So it'll be the written homework due exam and
Should we just print out the new?
what?
I'm a fan of just taking ink and slashing through and writing.
Just like it.
That's just
Why
me.
waste paper? Just write it down.
Which that Monday was? 20th?
That
No,
next
that's
Monday?
Next week. 5th, what'd you say?
Next Monday is the 20th. The following after
27th?
is 27th.
I guess it makes sense, right? 7 days. Yeah. 7 is 27. Project.
And then project 3 would be 8-3.
8-3?
Yeah.
Renee, what were we saying? Number 11? Or what
Number,
section?
can we start on number 10?
Number 10, what section?
10 is like much 3.6. The channel. So,
On the computer?
yeah. Do you want me to show you the work I had?
Yeah, my 3 point, my number 10 will not be exactly the same as number 10. Mine's e to the negative 3x squared, but I have about what you have.
Yeah, I got e to negative 4x squared.
Okay. So whatever. E to the negative 4x squared. I'm going to find dy dx. Use a chain rule. If it's negative 4x squared, it's going to put inside the exponential function, right?
Yeah.
So.
I did the second version.
Oh, you use versions? Okay. So, if we.
So y would be e to the u, right? Or no?
Okay. That's absolutely right. E to the u, and then u is negative 4x squared.
4x squared. Yeah.
Okay. So dy du times du dx is what we need, right?
Yes.
So the first one, dy du is what?
Wait, what did you say? dy du is e to the u.
Right, it just comes right back. Okay, e to the u. And what is du dx?
4x. No, negative 4x.
Negative 8x, right? That's the problem then.
Oh wait, negative. Oh yeah, negative 8x.
Okay, bring the 2 down. So times negative 8x. And now we just replace u with what it actually is. It's negative 4x squared. And we have our answer. Negative 8x e to the negative 4x squared.
But that's what I put in here, and it says that it's wrong.
It's wrong.
What does dy represent in the equation? Which number is it represent?
dy, just
Is
this little differential right here, dy,
Yeah.
is the change of the dependent variable, and dx is the change of the independent variable.
So dy or du, what does du represent?
Du, the change in this dependent variable, is dependent upon x, but over here, inside this function, is the independent variable. It plays a dual role, because it's like the in-between, in a sense.
This never made sense to me.
Hold on a second. Let's look at that real quick. So we have a line, right?
Yep.
And if I were to take this part of that, right, you would call this delta y. You call this delta x. Is that okay?
Yep.
That's a change in y over a change in x. We take that ratio of delta y over delta x for a line.
That's your slope.
That's the slope. Okay. Slope. Now we're just trying to do the same thing with any function. Even when it's not linear and the slope is not constant, we like to do the same thing. So now you give me a curve. Oh dear. Well, there's no delta y delta x constant for this thing. The slope is different everywhere, right? What we're trying to do when we take the slope of the tangent line, right? We create this line. Oh, we'll take the slope of this thing. We'll take this dy or this dx. That's what we'll do. Okay? But in the limit, as you remember the construction I made the first time we talked in chapter 3? That picture where we took the secant slope and we took the limit as the secant slopes approach the tangent slope.
So with secants on the inside of that curve.
I can pick it anywhere, yeah. Pick it there, right? There. And then it gets closer.
Yeah.
And eventually it's really, really super duper close to being the tangent line slope, right? So delta y and delta x are finite values here, right? This could be a 5, this could be a 4 or something, right?
Yep.
So, but when you're doing the limit, the delta y and delta x become infinitesimally small. So that's why it changes to that notation and that notation there, right?
So dy over dx is slope.
Because the delta x is becoming infinitely small, infinitesimally small. So it changes notation to being a dx instead of a delta.
So d represents the connection between the two?
d du is the rate of is how u is changing. Dx is how x is changing. So du dx is how u changes with respect to x.
How u change? What u represents x anyway?
No. U is a function of x. U is this inner function here. U is the inner function.
And x is e to the negative 4x squared?
Y is e to the negative 4x squared.
So what is x?
Okay? So y is a function of u. Y equals e to the u. But u, the thing inside here, we can call that one letter if we want, right? So u is a function of x. So u is the dependent variable in this problem, and it's also an independent variable in a way. It's independent as regards y, right? It's the independent part of this expression, but it's the dependent part of this expression. That's what happens when you do composition, right? You could say right now that y is a function of negative 4x squared, right? Y is a function of negative 4x squared. Now, all right, something else.
Are those meant to look like fractions or?
Yeah. They're meant to look like fractions. They're not.